Senyondo Lawrence, a mathematics teacher at Kennedy Secondary School, Kisubi, and today in advanced level mathematics, paper 1 strictly, according to the Ugandan syllabus, we want to look at integration 2. And we are recalling that integration is the process of obtaining the area under a curve. It's also important to note that it's the reverse process of differentiation. And under integration 2, we study the following techniques. We study the following techniques of integration. We study the following techniques of integration, namely change of the variable, in addition to the standard integration we know of x power n. We will do function and derivative. We'll do function and derivative. We'll do odd and even powers as a technique of integration, odd and even powers of trigonometric functions. Standard-wise, we normally focus on to sine functions, cosine functions, and where need be we may involve others, but generally we normally focus on to those 2, 4 integrals involving inverse trigonometric functions, integrals involving inverse trigonometric functions. 5 partial fractions, integrals that can be handled only when, dear viewers, you change into partial fractions. They are those specific integrals. Then there's what we call the parameter t substitution. 7 integration by parts. Normally this ends the story, but I want to mention that under inverse trigonometric functions, generally many students know that here we look at the sine and the tangent substitutions. In our discussion today, I want us to look at the change of the variable technique. And the change of the variable, and generally throughout the whole chapter, it is interesting that one must learn how to differentiate. For example, a case when u is x squared, one recalls under differentiation that du dx is the same as 2x. Those are the ideas that are very paramount here. Under integration 1, we are told that the integral of x power n dx is the same as x power n plus 1 over n plus 1. Standard special integrals. Generally, you recall that the integral of ax plus b power n dx would give you ax plus b power n plus 1 divided by a into n plus 1. This is a. Where I want to emphasize, remember to add c, where down here you multiply by the coefficient of the variable in question, and in the new power. Those are very important ideas. On addition, you must note that in our introduction, this is a reverse process of differentiation. You cannot handle very well integration 2 unless you know how to differentiate. Now, dear viewers, I want to emphasize that as regards integration, we will be separating these two terms. We will be separating them, and from this statement, one would agree with me that when you cross multiply, this statement becomes du, which is equal to 2x multiplied by dx. That is a very special statement under integration 2. So similarly, the quantity y equal to x cubed can be given as, in a similar way, can be given as dy equal to 3x squared dx. Yet still, one would say in the same style that dy by dx is the same as 3x squared, and then later cross multiplies. 1 times dy is dy, and this times the other gives us 3x squared dx. However, this end result after cross multiplication is the special interest. Without wasting much ado, let's look at examples. Dear viewers. Find part A. Find part A. The integral of x, the square root of 2x plus 1 dx. In such a question, you're required, if you're careful, to use the change of variable technique to integrate. Our interest will be to fall into a case where we can use our normal integration one. So in such questions, I want to emphasize, you should be able to notice that there is a term with a power a half. Remember, square root means the power of that term is a half, and there is a term with a power 1. We only focus on that term with whose power is a fraction as we let. For example, in our solution below, we will say let u be. I'm going to let u to be equal to that term whose power is a fraction. The technique is change of variable. So the variable currently that I'm introducing is u. That's the technique, change of variable. The variable that has been in question is x. The variable I'm introducing is u. From where you're watching from, you can use t, any letter here, y, z, among others. To differentiate easily, I'm going to eliminate the square. Remember, it is power half. So to eliminate it, I'm going to simply do a squaring both sides. On squaring both sides, I get u squared when it is equal to 2x plus 1. Then you differentiate. When you differentiate u squared, you get 2u, but you differentiate with respect to u. When you differentiate to x, you get 2. The derivative of 1 with respect to x is 0. Remember, 1 is a constant. I'm talking to that viewer who has a clue with differentiation. When you differentiate a constant, you get 0. So we are differentiating this side with respect to x. I want to emphasize, some candidate will go through the general differentiation style and says this is 2u du dx, which is equal to the derivative of 2x plus 1 is 2. Then later cross multiplies to get 2u du equal to 2 dx. Very important. However, let's focus here. According to our integral, there is no 2 anywhere, so feel free to reduce off by 2 both sides. This becomes u du equal to dx. So the dx which we are going to substitute for is here. And our x is in the equation. Remember, 2x plus 1 is equal to u squared. I need x. Remember, this whole term, we call it u. So I need x from here. Make 2x the subject. 2x is the same as u squared minus 1. Dividing both sides by 2, therefore x will be u squared minus 1 over 2. Now, here is where it is very enjoyable. In the integral of x, the square root of 2x plus 1 dx now becomes, where there is x, we are putting u squared minus 1 over 2. Where there is x, remember x, we have made it the subject. And this term is our new variable u. We called it u times u. And our dx, in the derivative process, our dx is u du. The integral, which was in the form of x, is now in terms of u. Remember, candidates, our first technique is change of the variable. As we noted, change of the variable. I've changed the variable from x to u, and then carry out the general process of integration. No more fractional powers. Smartly take out the half. This will be the integral of u times u, that is u squared into u squared minus 1 du. That becomes a half, the integral of open brackets, u squared times u squared, indices, dear viewers, that is u power 4, add powers, minus u squared times 1, which is u squared, and that is du. And then integrate, fix a half, integrate inside. U power 4 becomes u power 5 divided by 5 minus u power 3 divided by 3 plus a constant c. That does not end there. I want to close it up from here. It becomes a half into 1 over 5 u power 5 minus 1 over 3 u cubed. For further simplification, someone should be able to notice that u cubed is a common factor. The lowest power is u cubed. Take it out. Inside you will have u squared minus a third. U squared over 5 minus a third plus a constant c. And when you get the LCM, you have a half u cubed into your LCM, which is 15. 15 by 5, you get a 3. 3 u squared minus 15 by 3, you get a 5. Remember, you're adding a constant c. That gives us 1 over 30 u cubed into 3u squared minus 5 plus c. Remember, candidates, that the original question was in terms of x, but your variable which has helped you reach the final stages is u. Don't lose control. Don't forget to take it back to the original question. So at this stage, we are finalizing. We simply have to recall what is u. U is the square root of 2x plus 1, and then substitute back to end the stage. So we simply say, as we have noticed that our last stages are in terms of u, yet the original question was in terms of x. So our variable, we changed it to. We have to reverse it back to the original one. The question must be given, dear viewers, in terms of the original variable. So your final answer must be in terms of the original variable. U is here, so substitute back. This is 1 over 30 into 2x plus 1. It's power half, but here the whole term is raised to 3 into 3 into 2x plus 1. The term is power a half, but all squared minus 5. So simplifying this, we get 1 over 30 into 2x plus 1. 2x plus 1. Power 3 over 2 into powers multiplied by indices, a half times 2, you get power 1, so that is 3 into 2x plus 1 minus 5. and then open brackets, that is 1 over 30 into 2x plus 1 power 3 over 2 into, is that a 6x? That is a 3 minus 5. So if you're careful, 3 minus 5 gives you a negative 2, and you will say this is 1 over 30 into 2x plus 1 power 3 over 2 into, that is 6x minus 2. If you're careful, you all agree with me there is a common factor here, ability to simplify. The common factor is 2. Take out the 2. When you factorize out that 2x plus 1 power 3 over 2, take out the 2, then inside you will have 3x minus 1. 2 out, 2 hits back, you get a 6 here and a 2 there. This 2, I reduce it with 30. 30 by 2, you get 15. So resultantly 30 by 2 is 15. So resultantly, the integral of x, the square root of 2x plus 1 dx is equal to 1 over that denominator has become 15 into 2x plus 1 power 3 over 2 times 3x minus 1. Remember, we are adding a constant c of integration. Don't forget, we are adding a constant c. It's very important. It must be kept intact. It must be kept intact, though we are carrying out the process of simplification. B, change of variable. Change of variable. It can be a question on evaluation. For example, show that the integral from 2 to 3 of x, the square root of x minus 2 dx is equal to 26 out of 15. Show that. So with the limits, of course, you know that this is evaluation. So in other words, we are finding the area under this curve. Recall my introduction. So we will let, for example, u be the square root of x minus 2. This implies that u squared is x minus 2 du 2u du is equal to dx. The process I've explained it in part A on how to reach here. Then at this point we can also tell that x, if negative 2 crosses, it becomes positive, meaning x is u squared plus 2. You're ready to substitute. But in a question where you have limits, you cannot do away with the changing limits. After all, you are changing the variable. Remember, we are doing a subsection or a technique of integration called the change of variable. So if you change the variable and an integration question has limits as well, you change limits. So we are changing limits from x to u. Our lower limit is 2, our upper limit is 3. U is the square root of x minus 2. So when you substitute x here, you're getting u. X is 2, 2 minus 2 is 0. 2 minus 2 I'm putting here is 0, meaning I will have square root of 0, leaving u with a 0. Substitute 3, square root of 3 minus 2. That leaves me with the square root of 1. I take 1. The limits. Upper limit is 1, lower limit is 0. So our integral becomes, now the integral 2 to 3 of x, the square root of x minus 2 dx becomes the integral. Remember, we are changing the variable now, the limits must change. Our 2 has become 0. Recall from our table. Our 3 has become a 1. What is x then? X is here. We have x here as u squared plus 2. And also the square root of x minus 2, we got it. In our rating, we got it as u. We call it u. We are changing the variable, remember, and dx. Dx is ready for us to use as 2u du. Then product, keep out the constant 2, integrating from 0 to 1. This is u squared. U squared into u squared plus 2, the whole of it du. And that is 2, the integral from 0 to 1. Open brackets, you get u power 4 plus 2u squared. Du, integrate. You integrate, this becomes u power 5 over 5 plus 2u cubed out of 3. Limits 0 to 1. That 2 is waiting. Then we operate limits. From integration 1, we are all aware when you have limits, start with the upper limit to evaluate minus the lower limit. Our upper limit, put a 1 here, you get 1 over 5, plus insert a 1 here, you get 2 over 3. You will agree with me, dear viewers, that 0 implies this term is 0, 0 over 5 is 0, 2 times 0 is 0 over 3. The whole term will yield a 0. So we are remaining with 2 into a LCM, which is 15. 15 by 5 is 3, times that 1, 3. 15 by 3 is 5, times that, giving us 10. So resultant, I get 2 into, inside there I have 13 over 15, which gives me constant hitting a fraction. It hits the numerator. 2 times 13 over 15, which gives me 26 out of 15. Which is as required. This is equal to the right hand side. Remember, we carry on from the left hand side. You normally say it's equal to the right hand side, or you can say as required. So, dear viewers, wherever you're watching from, I want you to try for me. Simply try for me to evaluate. Simple evaluate negative 3 to 0 of x plus 3 out of the square root of 2x plus 1 dx. And as well, feel free to find, be waiting for your feedbacks, find the integral of x plus 2 into x minus 1 power 4 dx. It's where we'll begin from our next episode. Thanks for watching our episode for today under Integration 2. Follow us on Facebook, Lawrence Semyondo, and also where mainly you should be followed is our YouTube channel on Lawrence Semyondo. Don't forget to subscribe, and in our episodes, finding any challenge is not an issue. Please share with me on my WhatsApp number, and I will surely give you feedback. Let's keep in touch. Thanks for